hyperparameter tuning with a great search and random search. Welcome back to Python for AI and machine learning. I am Dr. Azad Rasul, and in this lecture, we are exploring hyperparameter tuning to optimize machine learning models. Hyperparameter tuning helps us find the best model settings to improve performance and stability. Today, you will use GridSearch and random search with a scikit-learn to tune our random forest model on the crop health CSV dataset. Let's dive in. Setting up the model and dataset. Let's load the crop health.csv dataset and set up our random forest model. Here is the code. It's already using GPU. Load crop health CSV dataset. Run the code. This loads the 1000 row dataset, cleans it, and split it into 800 training and 200 testing samples. The random forest model will be tuned to improve its cross-validation scores. Using grid search for hyperparameter tuning. Let's use grid search to test combinations of hyperparameters for our random forest model. Grid search tries every combination in a defined grid to find the best settings. Here is the code. Import GridSearchCV function. Define hyperparameter grid. Number estimators 50, 100, and 200. Max depth 3, 5, and none. Main sample split 2 and 5. Then initialize model. Model equal random forest classifier. Random state 42. Perform grid search. Grid search equal using the function GridSearchCV model comma param grid CV equal 5 scoring accuracy. GridSearch.feed using xtrain and ytrain, then print best parameters and scores. The param underscore grid tests 3 hyperparameters, number estimators 50, 100, and 200, max depth 3, 5, or unlimited, and mean samples split, minimum samples to split node 2 and 5, creating 18 combinations. GridSearchCV runs 5-fold cross-validation on xtrain and ytrain, selecting the combination with the highest mean accuracy. Let's run the code. Best parameters, max depth none, mean sample split 2, number estimator is 50. Best cross-validation accuracy found 4.98. Was mean of 4.86. But max depth of none risks overfitting as seen with the IUC of 1. run this code to see your best parameters. Now let's using random search for efficiency. GridSearch tests all combinations, but random search samples a subset, which is faster for large grids. Here is the code. From scikit-learn model selection, import RandomizedSearchCV. From scipy.states, import randent. Then define parameter distribution, number estimators 50, 200, max depth 359, mean sample split, randent 2 and 10. Perform random search equal randomized search CV with the model paramdist CV5 scoring accuracy random state 42 random search.feed xtrain and ytrain, then print best parameters and scores. The function randomized search CV samples 10 random combinations from the distribution using 5-fold cross-validation on xtrain and ytrain. Let's run the script. Our output shows best parameters, max depth none, mean sample split 5, number estimators 142, with a cross-validation accuracy of 0.98, matching GridSearch. The high mean sample split and an estimator suggest a slightly more constrained model, but max depth none still risks overfitting. Compared to previous lectures, with the mean of 0.86 and standard deviation 0.12, the 0.98 accuracy is a major improvement, but we will check stability next. Evaluating and applying the tuned model. Now let's apply the grid search parameters and evaluate the tuned model to confirm stability. Train tuned model with the grid search parameters using max depth 9, mean samples split 2 and number estimators 50. Random states 42. Evaluate test matrix. Import accuracy score, precision score, and recall score. Then print outputs. Check cross-validation stability on training set. Import cross-val score. C scores equal cross-val score using best model xtrain, ytrain, CV equal 5 scoring accuracy. Then print outputs cross-validation scores, mean CV accuracy, and standard deviation. In this code, we train the model with grid search parameters and compute test metrics. Let's run the code. Our output shows test accuracy 0.97, precision also 0.97, recall 0.93, matching previous lectures. The cross-validation scores 0.98, 0.98, 0.96, 0.99, and 0.97. Give a mean of 0.98 and standard deviation of 0.01, aligning with the GridSearch's 0.98, and the low standard deviation indicates consistent performance across folds, a big win for stability. However, max depth none and unchanged test metrics suggest possible overfitting. Try max depth of equal 5 to further reduce overfitting and improve recall for crop health predictor, ensuring we catch more healthy crops. Run this code and compare results. In summary, you have tuned your crop health model with a grade and random search, achieving a cross-validation accuracy of 0.98 and stable scores, mean equal 0.98, standard deviation equal 0.01, but test metrics accuracy 0.97, precision 0.97, and recall 0.93 suggests lingering overfitting with a max depth equal none. Complete the code exercise to test max depth equal 5 and improve recall. Take the quiz to test your skills and share your cross-validation standard deviation in the QA forum. I'd love to see your results. Let's keep mastering AI and ML.